guys, this is Ms. Howington here at Research Triangle High School, and today we are going to talk about chemical weathering. So, just to review, weathering is when rocks are broken down into smaller pieces. And again, there's two kinds of weathering. There's physical weathering and chemical weathering. Today we're just talking about chemical weathering. So weathering in general relates to the bigger picture of what we're talking about this year, because weathering is part of the rock cycle. It's a very important part of the rock cycle. It turns rocks into sediments that can then be eroded, or they can then be cemented and compacted and turned into sedimentary rock. Weathering also is the first step in soil formation in primary succession. So remember, this is when ecological succession is occurring. And that's that predictable change in the plant and animal community over time. But we're starting out with bare rock and absolutely no soil at all. All right, so chemical weathering, the definition of chemical weathering is the breakdown of rocks and minerals via chemical reactions. So remember, with physical weathering, there are no chemical changes made to the rocks. It's just physically breaking it down into smaller pieces. But with chemical weathering, we are changing the chemical makeup of the rocks. All right, so there are two main kinds of chemical weathering. So the first one we're going to talk about is hydrolysis. So this is a reaction between water and any other chemical or compound. So this can result in dissolving some of the minerals in rocks, or reacting with some of the minerals in the rocks to change them into different things. And so whether or not the rocks go through hydrolysis at all is going to depend on the type of rocks. So you can see on these rocks here, there's some pitting on the top of the rocks, most likely from some hydrolysis that has occurred there.
We are in the mountains of North Carolina and found this lovely waterfall here. So as this water is traveling over this solid rock, you can see down here at our feet that this is solid rock, so that's the bedrock. And so as this water is traveling over that solid rock, it's slowly carrying out little tiny chemical reactions and dissolving part of the rock and physically wearing away part of the rock and carrying it downstream with it. So this running water worn away the rocks that were once high up here on the sides, as you can see, and it's worn it down as it moves.
All right. So one of the things that leads to hydrolysis is acids in the waters. And so this is going to dissolve compounds in the rocks. These acids can come from a variety of places. It can come from natural sources like animal waste. So if you look at this rock here, it's covered in Nazca booby guano, which has uric acid in it, which is breaking down that rock. Lichens and mosses can grow on rocks. So, and as the lichens and mosses grow on rocks, or plant roots grow on rocks, they will excrete a type of acid onto the rocks, which will break them down. And then acids can also come from human sources. We get a lot of carbonic acid and sulfuric acid and nitric acid forming due to emissions from burning fossil fuels. All right, so just so that we are aware, as a quick review from chemistry, so carbonic acid forms when carbon dioxide interacts with water. You can see the chemical equation there. It would be a good thing to write this down and memorize it. Sulfuric acid occurs when sulfur dioxide is interacting with the oxygen and the water in the atmosphere. And this is one of the main acids that we see in acid precipitation or acid deposition. And the sulfur is coming most frequently from the emissions from burning coal. Nitric acid is another common acid we see that contributes to dissolving of rocks and minerals in rocks. So this happens when nitrogen oxide reacts with oxygen and the water in the air. And again, this is a large component in acid rain. All right, the other type of chemical weathering that we're going to talk about today is oxidation. So oxidation is when there is a reaction between oxygen and any other chemical or compound. Oxidation will change the color of rocks a lot of times. So it's a very visible chemical reaction. We see it a lot of times in rocks with high iron content. So you can see here these red rocks in Sedona, Arizona, get their red from an oxidation reaction with the oxygen in the air. So any type of chemical weathering, whether it's hydrolysis or oxidation, is going to result in softer, weaker rock that will break down much more easily, either chemically or physically. And then last but not least, a quick thank you to all of the photos and the sources that were used in this video. All right, guys, thanks so much. See you in class.